So the other way of looking at why we use the energies that we do, let's take another of the Sankey models and talk about efficiency, okay? Why do we use coal? Coal has a decent energy density, and if you look at the table for energy density, it has a fairly decent energy density. But it's not the greatest. But why do we use it? Well, every time you process an item, so you have coal in the ground. In order to dig coal out of the ground, we have to use energy. Okay? So energy is removed from the system. And mind you, we may be pumping a lot of energy out, but a big chunk of it is going to go towards removing it from the ground. And then we're going to put it through processing to get out all the impurities, removing another chunk of energy going through processing is removed from the system. So you got to use energy to process it. So a chunk of energy is removed from the system just to power equipment, if you will, and to do the extraction of coal. Coal then is processed and cleaned. So a large chunk of that is cleaned so that you have pure coal coming to the energy plant, which then will convert that coal into thermal energy, which is not an efficient process, into itself, and to be delivered to your household. So you start off with a lot amount of energy in this coal, and small chunks of it are being removed in every step. As a matter of fact, like I said, you turn it into thermal energy to move the turbine. A chunk of that is removed. Then it's used to send through power lines, and a chunk of energy is removed from there. On and on and on and on. But these two major arrows are being pulled out before it even reaches to a power plant. Okay? So looking at that process, coal is a two-step process to deliver it to a power plant. And over those two steps, I'm removing energy from the system. Now let's look at some of our biomass energies. Let's look at corn fuel. Okay? Well, corn fuel is a four-step process. You have your corn being planted in the field. Well, it's more than, maybe, in some cases it's more than four. So what you do is then you harvest it. That's energy being removed from the system in order to harvest that corn to be turned into biofuel. That corn is then processed, turned into a mash. So energy is being removed to turn it into a mash. We move on. I need more space. That mash goes through a series of enzyme reactions, and from there we get usable energy. But in every step of the way, I'm pulling energy out of the system. So the more steps I go through, the more energy is being removed to the system in order to get a little bit of energy out. So talking about biofuels, and especially talking about corn-driven biofuels, we have too many processes in the system in order to get energy out. Whereas a setup like coal, or even the case of oil, where oil is being removed, and then it goes through only one or two processes after that to extract gasoline, it's more efficient. There's less energy loss in the process compared to using a biofuel like corn to convert to ethanol. Now, the solution of that is not to use corn. Most of the majority of the excitement when it comes into biofuels is talking about algae. Algae then is harvested with a little amount of energy because you build large ponds and you just simply skim the pond to pull the algae out. You process the algae, you send it through one process because it's algae to convert it into a clean biofuel, into a form of ethanol, and that is then used. So you're reducing steps. Now, I only use 2 steps for corn, but there's actually more than that. There's a series of enzyme reactions that it has to go through, and every reaction, energy has to be removed from the system. It takes energy to do that process. So you get less and less out with every step. Where superalgae, the super biofuels, will have fewer and fewer steps. So in order to use biofuels like corn efficiently, we're going to have to come up with an enzyme that will take corn mash and convert it quickly in one step into gasoline, which isn't going to happen. Okay? But oil is a two-step process. Coal is a two-step process. They're far more efficient that way. Now, corn is reusable, where coal and oil are not reusable. Algae is reusable. Okay? We can produce algae at a rate that can be we call it reusable because we can produce as much as we need, where coal takes millions of years to produce. So it's it'll take 1,000,000 years to burn to make more coal. So it's not a reusable resource. But the idea is that some of these biofuels, and especially corn, is not a good way of producing energy because there's multiple places in which energy is lost. Okay? Where we use coal and oil primarily because there's fewer steps, even though it's not reusable. Now, nuclear energy on that, there's multiple steps on nuclear energy to get energy out of it. But nuclear energy has a high energy density. If you can find a good source of uranium, you're talking maybe more than a half dozen steps to produce a nuclear pile, and each one of those steps pulling energy out. So think of there's six piles to get to a point where I have nuclear energy to a point that's usable. Centrifugal machines, doping it by striking it with more atoms, so it has more neutrons, making it more unstable. Moving it along those processes. Each one of those processes require energy, but because of the high energy density of nuclear energy, it's efficient. Now, us in the United States, and this drives me crazy every time I hear it, and we just hear Barack Obama moving a nuclear power plant ahead and approving a grant to build a new one. The problem with nuclear power in the United States is that we have no high-quality nuclear power. It's going to take, instead of 6 steps, or whatever steps it may take for European countries to produce nuclear power, we have to use low-quality uranium, which is going to take 8 or 12 steps to get to the point where we have a good quality source of uranium to produce energy in a nuclear power plant. So that's why there hasn't been a real push for nuclear power in the United States, because we don't own a good source of nuclear energy, where the European countries do. They have far fewer steps to take, therefore they have far less energy loss. Okay? Cool? So that's another way of looking at efficiency and kind of giving us an idea of why we use the energies we do. Why is coal and oil predominant, even though they're non-renewable and they're hazardous to the environment? Because there's less energy loss in the process, where our biofuels have multiple processes to get to a usable form. Therefore, there's multiple steps in which we lose energy. So we get less out of it. So the trade-off is that there's tremendous amounts of energy coming out of gas or out of oil compared to the amount of energy that's being put into it. And there's very little energy that we're getting out of biofuels compared to the amount of energy that we put into it. Now, solar energy, there's a lot of energy that goes into solar energy. The production of the panels themselves are very expensive, and then the installation and all that other stuff. The advantage of solar energy, even though it's very inefficient to build a panel, once the panel is in place, that energy is free. It's just simply gathering sunlight and turning it into electrical energy. So the base energy that we have is infinite. If you think about it, if you look at, well, not quite infinite, but if you look at the amount of energy that strikes the Earth, that's a huge amount of energy. So even if we're losing 95% of that energy into production, that 5% that we're getting costs us nothing to keep that going. Well, I mean, there's maintenance costs, but that's not significant compared to the amount of energy that we're going to get out of the lifetime of a single panel. Okay? This is another way of looking at energy efficiency.